This week on The Catalyst, we're talking about an infectious disease called schistosomiasis. Although it is not common in Australia, we are still at risk of being sick, especially those traveling to tropical countries. The parasite Schistosoma mansoni causes this infection, and it is prevalent in developing countries within Asia and Africa. It is not as well known as malaria or as alarming as Ebola, but it still affects over 200 million people worldwide. Earlier this year, a study was conducted that identified another possible cure for this debilitating disease. Today, we have Dr. Shazia Ali from the World Health Organization to talk to us about this new research. She is currently in Brisbane to meet with researchers from the University of Queensland and James Cook University about their groundbreaking cure for schistosomiasis. Glad to have you here today, Dr. Ali.
Glad to be here.
So, Dr. Ali, tell us about schistosomiasis.
As you mentioned earlier, schistosomiasis is a parasite that targets the hemoglobin in the blood and uses this as their food source. This can weaken us easily. Some side effects include iron deficiency and malnutrition.
This seems like a very serious disease. Those side effects sound like they could lead to mental and physical deterioration, especially in these developing countries.
Definitely, especially when children are infected.
Is there a cure for this?
Currently, the only treatment is the chemotherapy Prosuncatel. It is very effective, however, it does not prevent reinfection. That is why this new strategy is so innovative. It not only treats people that have the disease, but also vaccinates them.
So how exactly did this cure come about? What is it made of? I heard that this new treatment was aimed at neutralizing schistosoma's digestive enzymes and gut proteases. This way it can't acquire any nutrients at all.
Exactly. The main digestive enzyme they're targeting is D-aspartic protease or SMCAT-D. So the treatment they created consists of an A263K epitope combined with an alpha helicity promoting sequence and a promiscuous T helper epitope P25.
I see. And then does it self-assemble into a secondary structure to immunize the patient?
Yes, it does.
Have we carried out any trials for this?
As far as I'm aware, a clinical trial was carried out on mice, and this experiment successfully demonstrated the vaccine's ability to cure and induce antibodies against schistosomes in the mice.
Let's hope this treatment makes it through to human clinical trials. It sounds like an extremely valuable and beneficial cure compared to what they are using now.
Definitely, working out who is important to being proactive against diseases and preventing future infections or reinfections. This research provides a strong foundation for the development of a combined immunogenic vaccine and cure against other infections. Additionally, it is extremely useful, particularly in Asia and Africa, where treatment costs can also be a major issue.
Thank you for coming here today, Dr. Ali.
Thank you for having me.
That was Dr. Shazia Ali. Thank you for watching, and we'll see you again next week on The Catalyst.